In this video, we're going to talk about the scientific concept of power. So power is another word that has a little bit different meaning in real life than it does in the scientific sense. So power in real life, we can think of people who have power, right? The president has power, or we can think of how much power we use in terms of electricity, right? So that's actually the scientific idea of the word power. So power is the rate at which work is done. So it's essentially how fast an object or a person or whatever is able to do work. Right? So if something is doing work at a faster rate, it's going to have a higher power. If it's doing work slower, if it accomplishes the same amount of work in a longer period of time, then that would be less power. Right? So power is basically a speed, how fast we're doing work. Right? So the units for power are in watts. Right? So don't get this confused. The concept of work that we talked about, we use W as the variable for work, but W is also the unit representation of watts. Right? So power is measured in watts, but this W is not the same as the W variable we use for work. So when we write this formula, power equals work over time, we can represent it as P equals W over T. The W in this formula is for work. Right, it matches up with this formula up here. The W in this formula is not for watts. So when you get a question and it has watts in it, do not just think, oh, I'm going to plug that into the W spot, because the watts are measuring power. Right? So power is in watts. Do not get the W's confused. Right? So the power formula, it's just a pretty simple formula here. Power equals work over time. We can actually use the same triangle that we used for the density formula and adapt it for the power formula. Right, so we can say power equals work over time here. And again, whatever you want to find, just cover it up and do what the triangle shows you to do. So if we want to find power, obviously we divide work and time. So if we look at the triangle, that agrees, right? If we cross out power here, we would do work divided by time. If we want to find time, we would cover up time and we do work divided by power. Right, so the triangle that we are familiar with from the density equation can also be adapted to use for this power formula. All right, so let's try out some examples here of the power formula. So for the first one, it says a person takes 20 seconds to do 500 joules of work. How much power? All right, so we need the power formula. Power equals work over time. So the information we have here, we have the time is 20 seconds. We have the work is 500 joules, and the power is our unknown. So to plug into the power formula here, real simple, power equals work over time. Power is our unknown, it will stay as an unknown. The work was 500, and the time was 20 seconds. So here all we have to do is divide. You should get an answer of 25 here. And the units, again, are watts. All right, so 25W means 25 watts. It has nothing to do with work other than how fast the work is done. That's what power means. All right, so using the power formula, pretty straightforward. We could have done this with the triangle as well, obviously, but this one was pretty straightforward. So the second one, it says a motor has a power of 300 watts. How much work will it do in 4 seconds? All right, so here we have power is 300. We have, power is 300. We have work is our unknown, and we have time is 4 seconds. All right, so to find work here, we're going to use the power formula. So we have power equals work over time. Power is 300 watts in this case. The work is our unknown, so it'll stay as a variable. And our time here is 4 seconds. All right, so we could do two things here. We could use the triangle. And in this case, we're looking for work, right? So if we cover up work here, we're doing power times time in the triangle. All right, so that would give us work of 1,200 when we multiply those together. Our units for work that we learned, joules. All right, so again, even though it's a W here, do not get confused with the watts. The units for power are joules. All right, so the other way we could have done this, if you don't like the triangle, we could do this mathematically. To get work by itself here, we want to get rid of the 4. To get rid of something, we do the opposite of what it's doing. So the 4 is being divided right now, so in this case we would have to multiply by 4. And again, same thing to both sides. So 4 over 4 would give you 1, that will cancel out. So here we would do 4 times 300 to get the work, and that again would be 1200 joules. So either way, mathematically or using the triangle works. No pun intended. So let's try a couple more examples here. We have a person using 200 watts of power for 17 seconds. How much work was done? Okay, so we have power 200, work unknown, time 17 seconds. Alright, so if you want to pause the video and maybe try out these examples on your own and then come back and check your answers, that would be great. Otherwise, I'll show you them worked out here. Alright, so again, power formula. So the power is 200, work is our unknown, time is 17 seconds. So what do we have to do here? Well, we want to get rid of the 17. Opposite of what it's doing, we would multiply because it's being divided. 17s cancel out there. So we have the work is 3,400. And again, our units for work would be joules. Okay, so we could have done this with the triangle as well. Again, I'm not going to show that. It was the same as the last example. If you cover up work, we would do power times time, and you would get the same answer there. Alright, so for this last example here, we have a horse using 500 watts of power and doing 2,500 joules of work in the process. How long did it pull the sled for? This is asking for the time. Okay, so we have power is 500 watts, work is 2,500 joules, and the time is our unknown. Okay, so the triangle is a pretty easy way to do this one. The math gets a little complicated for this. We have power equals work over time in the triangle. We're looking for time, so we're going to do work divided by power. All right, so we would do 2,500 joules divided by the power of 500 watts, and we would just divide these out here, and we would end up with 5 seconds. All right. So if we do this mathematically, though, we have all the same variables here. That eraser is too small. We have all the same variables here. I'm just going to give up on the eraser. We have all the same variables, so we would need to do the power formula again. We have 500 for our power, 2,500 for our work, and time is our unknown. So to solve this mathematically, the best way and the easiest way to do it would be to cross multiply. So here if we take this 500 and divide it by 1, that's fair game mathematically because we can divide anything by 1 and it doesn't change its value. Alright, so if we put a 1 down here, then we can see how this could be a scenario for cross multiplication. Alright, so if we cross multiply here, we'd end up with 2,500 for our first cross here, and that would equal, we set the crosses equal to each other, and we would get 500t for our second cross. From here, we want to get t by itself. We'd have to get rid of the 500 over here, do the opposite of what it's doing. It's currently being multiplied by t, so the opposite would be division. We divide here, again, do the same thing to both sides. 500 divided by 500 cancels out to 1, and we end up with 5 seconds for t. Alright, so mathematically or using the triangle, you'd get the same answer here. Use whichever way you're more comfortable with. That's about it for power. Thanks for watching the video, and I'll see you in the next video.